Hello everyone. My name is Yash Mahajan and I am currently pursuing my first year in the MC program. Today I will be presenting on DSA. My today's topic is insertion sort. So this is the introduction of insertion sort. Insertion sort is a straightforward sorting algorithm used in data structure and algorithms. It builds a sorted array, one element at a time. The process involves taking the next element and inserting it into its correct position within the already sorted part of the array. To achieve this, elements are shifted if necessary to make space, while insertion sorts time complexity in the worst case is 0 in bracket n to the power 2. It's perform efficiently on smaller or nearly sorted data sets, making it an adaptive algorithm that can be useful in specific contents. So this is the class diagram. Class diagram shows the how we can arrange the elements in the order. First one is initially. There are given data set in which we have arranged the elements step by step. We can take first step. We start from the second or first block. We arrange letters in a small ascending or a descending order. First step means we have to take one box, compare with second box, and then the second one compare with third, and the third one compare with fourth. As well as this process after complete, your data will get sorted. This is known as insertion sort. And this is the process. And this is the diagram for the insertion sort. How the insertion sort works. Class diagram. Here we have the class diagram for insertion sort. This diagram breaks down how elements are systematically organized and positioned within the list. Insertion sort splits the array into two parts, one sorted and one unsorted, with each iteration. It takes the first element from the unsorted section and places it into its correct position within the new position. This systematic approach makes insertion sort predictable and straightforward. Time complexity. Next, let's look at the time complexity of insertion sort. In the best case scenario, if the list is already sorted, the time complexity is O in bracket n, as only one comparison is needed for each element. In the average case, when elements are randomly ordered, the time complexity is 0 in bracket n to the power 2. The worst case scenario also has a time complexity of 0 in bracket n to the power 2, which happens when the list is in reverse order requiring maximum shifts. The quadratic time complexity limits insertion sort efficiency on large unsorted datasets, though it remains efficient for smaller lists. Space complexity. Moving on to space complexity, insertion sort is very space efficient. It has an auxiliary space complexity of O in bracket 1 is it sorts the element within the original array without needing additional storage. This make it an in space sorting algorithm, a characteristic that is particularly valued in memory constrained environments or application where space efficient is a priority. Now we can see the advantages of insertion sort. First one is simple to implement. Second, efficient for a small data set. Third, performs well on nearly sorted data. Fourth, is stable sorting algorithm. Fifth, in place sorting requires no extra space. And sixth one, adaptive to partially sorted area. And the next is disadvantages of insertion sort. First one, inefficient for large dataset. Second, m complexity of O in bracket to the power 2 is the worst case. Third, not suitable for large random data. And fourth, high number of shifts and comparison. Application of insertion sort. First, small input size. Second, nearly sorted data. Third, online algorithm. Fourth, adaptive sorting. And next, objectives. First one, insertion. Second, shifting. Third, comparison. Fourth, traversal. So here our topic is completed. Thank you.